start.
Hello everyone, this is Annapurna SK and we are from GMU University, Damgere, and we are now doing a project-based learning. Topic name is IPL score prediction. So here's the first slide. So alright, let's talk about cricket. We all love the thrill of IPL, right? But have you ever wondered, can we actually predict the scores before the final over drama unfolds? Well, that's exactly what we are diving into today. Traditionally, prediction scores was like playing a guessing game. Experts relied on past experience and gut feeling. But here's the catch. Cricket is wildly unpredictable. Factors like pitch, conditions, weather, and even dew can completely change the game. One day, a pitch is a batting paradise, and the next it's a bowler's dream. That's where machine learning steps in. It analyzes massive amounts of historical match data, who played, where, when, and how to make data-driven predictions. Think of it like a cricket oracle, but instead of magic, it uses math and patterns. So the next slide is about justification. Now, why should we care? Well, imagine your team strategist knowing the predicted score helps you plan whether to go aggressive or play it safe. Fans also love it because, let's be honest, who doesn't want to flex their cricket knowledge in front of friends? And here's the fun part: fantasy cricket and betting markets thrive on this data. If you could predict match outcomes accurately, you could be the next fantasy cricket champion. Plus, sports analysts and commentators use these predictions to make the game even more exciting. So, in short, machine learning is turning cricket into a game of strategy, not just skill. And who knows, maybe one day we won't just predict scores, but entire match results. And now the further topics will be explained by Kaustuba. Thank you.
Hello everyone, I am Kaustuba, and today I am gonna be discussing about the identification of the key variables. And in this part, we focus on understanding the variables that influence the predicted scores in a cricket match. And machine learning models rely heavily on the choosing the right features, and here we have categorized them into a two types. uh, Dependent variable it is an input feature. These are the factors that influence the final score prediction. uh, Overs completed, this include how many overs have been played so far. It helps estimate the game's progress. For example, if if when 15 overs are completed, then the remaining overs are scoring potential can be assessed. Wicket lost can be assessed by the number of wickets lost directly impacts on the scoring rate. Fewer wickets lost means that teams can play aggressively, while more wickets lost usually leads to defensive play. And then current run rate can be assessed by or it is calculated as the total run score divided by the overs bowled. And then a high run rate suggests an aggressive batting approach, while a lower rate might indicate a struggle or a good bowling from the opposition. And batting teams and opposition teams, different types have varying strengths and strategies and historical performances. Some teams excel in chasing scores, while others might perform better setting target. And then moving on to the next point, that is venue and weather conditions. The ground size, pitch type, and even the weather conditions like humidity or rain affect scoring patterns. Some stadiums are known for high scoring games, while other favor bowlers. And then the next point is the dependent variable output. The primary goal is to predict the final scores of the batting teams at the end of the innings, and the accuracy of the prediction depends on how well we interpret the input features. And moving on to the next slide, we have uh, data collection. And in here, we are talking about the data is the foundation of the machine learning project. To build an accurate prediction model, and we need need a rich and diverse data set. And here the data points like Kaggle data sets. Kaggle offers a variety of cricket data sets, including IPL match data and ESPN Cricinfo, a reliable source for historical and live cricket data. And then we're moving on to the next point, that is official IPL stats. Authenticate data from the Indian Premier League websites containing detailed match statistics. And then the next point, the data processing. Once the data is collected, it needs to be cleaned and prepared before feeding it into the machine learning models. Some common processing steps include handling missing values. Incomplete or inconsistent data can affect the model's accuracy. And then the next point is the technique like mean imputations or interpolations are used to fill missing values. And feature scaling. Features like run rates and overs completed might be on different scales. Scales ensures all data points are treated fairly by the algorithms. And next is the encoding categorical variables. Variables like team batting and venue are non-numeric and need to be converted into numbers. One hot encoding is often used for this. And next slide will be discussed by Vinuta.
I am Vinita. Now I am going to explain by algorithm selection. Machine learning models used random forest ensemble learning. This is powerful algorithm that builds multiple decision trees and combines their prediction. XGBoost gradient boosting, another ensemble method that sequentially builds trees where each tree corrects the error of the previous ones. It's often highly accurate and efficient. Next point, multiple linear regression benchmark model is simpler traditional statistical method that assumes a linear relationship between features and that target variables. It's often used as the baseline to compare the performance of more complex models. Next slide. Evaluation matrix used. Root mean squared error measure prediction accuracy. It calculates the square root of the average of the square difference between predicts and actually values. Sensitive to outliers, larger errors have a impact on RMSE means absolute error. Capture error magnitude, it calculates the average of the absolute difference between predicted and actually values. Prediction accuracy, it calculates the square root of the average of the square difference between predicts and actually values. Next point, sensitive to outliers, larger error has a bigger impact on RMSE. Next point, R squared measures how will future explain score variance. It indicates the proportion of the variance in the target variable that is predictable from the futures. Next point, model comparison based on this matrix. The chosen model will be the one that performs but best according to this matrix best dependence on the specific goals of the project. For example, if outliers are a concern, MAE might be over RMSE. Next slide.
Discuss about the implementation and feasibility of the our project-based learning idea, that is IPL score prediction using machine learning. In this section, this describes the tools and challenges involved in this project. Here we are going to use the tools and technologies such as the programming in Python with libraries like Pandas, NumPy, Scikit-Learning, and XGBoost. Development using Jupyter Notebook or Google Colab. Challenges and feasibilities of this project are real-time data integration. The system requires a continuous update with live match data. And data limitations, rare match scenario have been insufficient historical data. And then moving to the next slide, that is conclusion and future scope. In this section, this discuss the potential improvement and scalability.
using deep learning algorithms for better series forecasting, integrating the real-time data streaming, the web scraping or APIs, adding win probabilities prediction along with a score forecasting, scalability. The approach can be extended to other cricket leagues and formats. Overall, these projects help to evaluate the process, implementation strategy, and challenge for future enhancement for a machine learning based sport analytical project. Thank you.